Hello everyone, welcome. My name's Colin Benoit, and I'm a senior cinematics artist here at Epic Games. In this video, I'm going to demonstrate the features of the Virtual Camera plugin, introduced in the 4.20 release of the engine. If you haven't already, I would suggest looking at the online documentation for how to download the app, enable the plugin, and get started. We'll be using the Virtual Camera sample project today, which you can download from the Learn tab on the Epic Games launcher. The first thing to mention here is that this scene is running entirely on the PC, not on the iPad. The video from the Pi window on the PC is broadcast wirelessly to the iPad, with touch input and tracking data being sent back to the PC to drive a Cine Camera in the scene. You can move through the scene by walking around like this. You also have access to joystick controls by tapping on either of the docked analog sticks at the bottom of the UI. The left analog stick is for moving forward and back and side to side based on the orientation of the iPad. The right analog stick booms the camera up and down by default in global space. The focal length is displayed in the top left region of the UI. Click on the drop-down arrow or focal length value to expand a scroll wheel with a customizable lens kit. Use the scroll wheel to cycle through lenses in the kit. You can also click on a focal length directly to switch to it. By tapping the arrow in the top right corner, the scroll wheel changes to a fully analog zoom. The double arrows adjust the focal length by 10mm increments. Closing the analog zoom will snap the focal length to the nearest kit lens. The focus distance and aperture are displayed in the top right region of the UI. Together, these are used to set focus. Expand this drop-down to reveal two scroll wheels, one for focus distance and the other for aperture. To set focus distance, simply tap on an object in the viewport. You can also use the scroll wheel for fine adjustment. The double arrows adjust this value by 3-meter increments. Use the aperture scroll wheel to make the depth of field shallower or deeper. Both scroll wheels can be collapsed by double-clicking on them. There are 3 methods for setting focus. These are represented by the M, T, and A buttons just above the focus dropdown. By default, the focus mode is set to manual. That will set focus distance to a constant value each time you tap the screen to focus. Changing the focus mode to tracking will continually update the focus distance to keep the selected 3D point in focus. So if I move further away, that point stays in focus. Changing the focus mode to auto will display a reticle that can be moved around the screen. The focus distance will continually update to keep whatever is under the reticle in focus. It's important to note that touch focus is only active when the focus dropdown is expanded. When this is closed, touch input will not affect focus. This is to prevent accidental focus adjustments. In the bottom right corner is a blue button for creating waypoints, which are simply saved locations in space. These are useful for teleporting around a map. Tapping the caret next to the waypoint button brings up the waypoint submenu. This contains a home button that removes all offsets and teleports the camera to a designated home waypoint. If no waypoint has been designated as home, the camera will teleport back to the player's start, in the case of ARKit and Vive tracking, or will reset the camera to 1:1 within the mocap volume in the case of live link tracking. The second button on the waypoint submenu is for loading waypoints. This is also where a user can specify a unique home waypoint, as well as delete a waypoint. At the bottom center of the UI is a button for loading up performances. Once a performance is selected, you have the ability to play, pause, rewind, and scrub using the timeline. Note that for any performance for which you want to shoot camera coverage, be sure not to have a camera cuts track in Sequencer, as that will conflict with live camera tracking. In the bottom left corner of the UI is a red button used for recording. Tapping this will start the recording and stop the recording. You can then review your recording using Sequencer. Under the hood, the Virtual Camera recording uses Sequence Recorder, and in fact, changing parameters in Sequence Recorder, such as sequence name, sample rate, which actors to record, etc., will be reflected in the recordings from the Virtual Camera. The caret next to the record button expands the record submenu. This contains a button for taking high-res screenshots, as well as a button for loading previous screenshots. The act of loading a screenshot moves the camera to the location of where the screenshot was taken, much like a waypoint, and adjusts focal length and aperture to match. If you tap and hold the submenu screenshot button, it swaps out the main record button for a screenshot button. This is helpful when you're scouting locations that have no need to record camera motion. Simply tap and hold on the submenu screenshot button again to swap back to a record button. Jumping back to the top of the UI, in the top left corner is a button for UI visibility. This is customizable in the settings menu. In the top center of the UI is an informational section showing the slate name, which corresponds to the sequence name field from Sequence Recorder, as well as the FPS of the upcoming recording. In the top right corner is the settings menu. Inside are a number of tabs. In the general settings, you can switch the input source for camera tracking. By default, it will use ARKit, but the plugin supports LiveLink and Vive input. The custom option is a placeholder for other input sources that a customer may have in-house. In this menu, you can also set the performance playback to use timecode or frames, as well as toggle on or off global boom. The Film Format Aspect Ratio tab allows you to choose from a list of predetermined film formats and mats, both of which are customizable through arrays on the Cine Camera component of the virtual camera pawn. You can also set the matte opacity. The Focus tab gives you access to the focus method. These options are identical to the MTA buttons on the main UI. The display format of the focus distance, whether or not to show the focus plane when using touch input to focus, and what the color of the plane will be. The Stabilization tab is used to dampen the motion of the tracking input, giving the user a smoother, less shaky camera move. As you can see, I have these numbers cranked up quite a bit for the demo. Be mindful that this will introduce some lag the higher the stabilization. In addition to different values for position and rotation, you also have the ability to adjust stabilization per channel. Axis locking will stop the input source from affecting that specific axis. It's based on the direction the camera is facing when the axis is locked. For example, locking the truck and boom will force the camera to only move side to side. This is a great way to quickly create a linear dolly track. By default, locking Dutch will zero out the roll in the camera, keeping the horizon level. If you don't want this, uncheck the Set to Zero checkbox. When an axis is unlocked, the camera will again inherit the position and rotation from the input source of that axis. Motion scale is used to amplify the motion of the input source. This allows you to exaggerate or minimize your movement as you walk around a scene. You can see here that I have this scaled up. The scale on all three movement axes can be adjusted independently. Additionally, the truck and dolly can be linked so movement on the XY plane is uniform. Hitting the double arrow next to each of the scroll wheels adds 10 times the scale value, and there's a button on the bottom for resetting the scale back to 1. On the View Freeze tab, hitting the Freeze the View button will temporarily disable the input source, so the view on the tablet freezes, allowing the user to move the tablet somewhere else in the real world. Hitting Unfreeze the View will then re-enable the input source, but keeps the view offset. So this is particularly helpful if a user wants to reorient the scene in relation to the real world, or wants to simply be more comfortable holding the tablet while scouting or shooting. The Visibility tab allows the user to choose which UI elements remain visible when the Visibility eyeball button is tapped on the main UI. Presets allow a user to save specific settings and load those back during another session. This can be useful if you've come up with settings to emulate, say, a specific camera rig like a Steadicam or a drone. In this case, camera settings refer to focal length and aperture. By default, the plugin will save the current camera settings when you close the Pi window, so you don't have to continually reset them each time you launch Pi. Well, that pretty much wraps it up. I hope that was informative, and have fun playing with the virtual camera.